Okay, this is chapter 6.2 on graphing linear relations in grade 9. The section part, the section 2 part or 6.2 part of this chapter is really, really easy. And all it does is it allows or it uh, uh, trains you or teaches you how to interpret a graph using these two words. And the two words that we're going to use, I'm going to take a new page here for 6.2, is interpolation and extrapolation. So tonight at dinner, when you're sitting down at the dinner table and your parents ask you, like they always do, what did you do in school today? You can make it sound like you studied something very complex by saying to them that you studied interpolation and extrapolation of data. And interpolation is when we think about inter, it's reading in between known points. In between. So the interpolation is reading in between points, and extrapolation or extrapolation is reading beyond. That's boy. BEYOND, known points. So for example, if I had a graph and I knew this point, and this point, and there's my line. So these 3 points form a line, or they have a linear relation, and we know that they would have values that could be in between. So if I was to say this is 1 kilometer, 2 kilometers, 3 kilometers, and this was, we'll say $50 to go 1 kilometer, $52 to go 2 kilometers, and $54 to go 3 kilometers. I don't know what it's about. But what this means is if I was to interpolate data from this graph, I could take, if I said, well, how much for 1.5 kilometers, right? So what I would do is I'd say, well, 1.5 is here. So if I go up to here and then go over here, I could interpolate that, therefore, 1.5 kilometers, according to my line, would be about $51. Okay? I did not apply a linear equation. I did not substitute a variable. I did not put, this is distance and this is cost. I did not substitute for my D and solve for my C like we did in section 5.1 or 6.1. I simply used the line and I interpolated the data. Now to extrapolate data, since I only know these 3 points, if I was to say how much for 4 kilometers, well, that's more than the data has. But what I could do is I could extend my line or go a little extra piece and put it there, and then read this point according to what, if I went beyond the line, and I could say that, well, therefore, 4 kilometers, if I extend my line, would be $56 according to my line. Okay? So the two words we use in chapter 6.2 are interpolation, which is reading in between points that you know, and extrapolation, which means extending the line that you do know, the points that you do know, and placing a point on the line so that you can interpret the graph that way. And that's all we have to learn about. Now, your first show you know in the chapter says this graph shows a plane's altitude as it lands. The relationship between altitude and time is approximately linear. So here, as we look at our graph, we have our x-axis is now representing time, and it's in seconds. So we know that it's 20 seconds, 40 seconds, 60 seconds, 80 seconds, 100 seconds, right? So at 0 seconds, meaning when we started the time, when the plane started to land, the altitude in kilometers of that plane when it started to land was 20 kilometers above the Earth. And then after 20 seconds, as it starts to descend, we could interpolate by going up here, right? We could interpolate that at 20 seconds after it started to land, it was approximately, I could guess I have no real idea, but I could guess probably what? Well, it's going to be more than 15, probably 16 kilometers above the Earth. That's interpolating the data, right? Et cetera, et cetera. But the question it asks us is what was the plane's approximate altitude at 50 seconds? So right here, we would have 50 seconds, right? That would be 40, 60. So if we go up from it and go over here, we can say at 50 seconds, through interpolation, the approximate altitude was 10 kilometers above the Earth, okay? And that's just reading between the 2 points that I do have. The second point says at what time was the plane's altitude approximately 11 kilometers? So if I think about 11 kilometers as being roughly there, and I go straight across, once I hit this line here, I can go down and say, I don't know, maybe 45 seconds, right? Because midway between it would be 50. So I could say probably at 11 kilometers high, it was probably 45 seconds into its descent, based on interpolation again. And the last one says, is it appropriate to join the points with a straight line? Well, yes, I suppose, because what we are saying is that it descends at a constant rate. So if the plane descended at a constant rate and at constant speed, then this would be linear. But if it descended, if it hit little air pockets or if it hit turbulence or whatever and went up and down, that would affect its rate of descent and the time it takes to land. But we can assume that, yes, it's appropriate to join those points because it is descending at what we would assume to be a constant rate. The second show you know, it says the value of a computer decreases over time. The graph shows a value of a computer after it was bought. And when the value of something decreases, that's called the depreciation. So one of the things that depreciates the most is cars. Once you take it off the lot, it depreciates, I think they say like 10% once it drives off the lot. And after the first year, it loses about 25% of its value. So the graph shows the value of a computer after it was bought. After what approximate period of time does the computer have no value? So if we first look at it, time is here and value is here. So value of 0 is right here. So if we extend the line, oops, maybe I can't draw a very straight line, but if I extend the line here, that's not very good. I can extrapolate beyond the points that I know, and I could say that if I extend this line, approximately after 5 years, a computer has 0 value. It's not worth anything anymore. Nobody wants it because it's antiquated, right? It's kind of like my iPad I have at home. I have an iPad mini, and Apple stopped servicing it or updating it, so I can't do anything with it anymore. It's like a glorified calculator. It's awful. Yes. The second part says, when was the computer worth approximately $200? So again, I had to extend the line here. So I extended beyond the points that I knew. And if I think about $200, it would be right there on this line. So when was the computer worth approximately just $200? 4 years after I bought it. Right? I extrapolated that information. I went beyond the points that I knew. And the last part says, is it appropriate to join the points to form a straight line? I suppose so, because we're assuming that it decreases at a constant rate and that at 5 years it is worth nothing. Obviously, after 6 years, it's not going to be worth negative value. So the problem is the line would not continue forever straight. It would go to here, and then it would go this way, right? But the truth is, yes, but the truth is sometimes, maybe 20 or 30 years down the road, it might start to have value again, right? Because now it's an antique, just like cars. You know, it's never worth nothing, and sometimes it does go back up in value depending on if it's antique. So we could say, is it appropriate to join the points with a straight line? Yes and no. Because later on, it may appreciate in value because it's no longer, maybe the parts that are in it are now worth something because they have precious metals in it or something like that.